Now, at the second part of this presentation, we'll discuss about inference on the overall effect size. And again, before we continue, I would like your thoughts on this. So have you ever used different methods to calculate the uncertainty in the overall effect size? So the majority of you, again, use the default option in the relevant software. So again, that is what I actually expected. The good thing is that many of you, some of you actually, have used different methods according to their meta-analysis needs or in different meta-analysis. So again, we need to explore this further according to the meta-analysis, the meta-analysis that we have and the characteristics of the meta-analysis that we have. So as you will see, we're going to see that there are several methods that we can use for the to calculate the uncertainty in the overall effect size. So in an empirical example that was conducted by Cochrane et al. And was published in 2014, that the authors include 9 studies in this example. The authors applied different methods to estimate a confidence interval for the overall effect size. So in this example, you may see that the widths of the different confidence intervals differ, and it is uncertain which method is more accurate. Also, typically, although this is by no means suggested, researchers evaluate results in terms of whether a confidence interval crosses or not the line of no effect. So the question now is, which is the most appropriate method to use? Again, we conducted a search and we identified 15 methods to compute a confidence interval for the overall effect size. And we grouped those confidence intervals in several broader categories. The properties of those methods were evaluated in 30 simulation studies and 32 real-life data studies, comparing at least 2 methods. So for those interested, these are the formulae for the confidence intervals. I will not get into the details of these. More details can be found in our paper that was published recently in the research synthesis methods. And briefly, you can see that we have 3 wall-type methods. The Hartung-Knapp-Seydig-Jonkman method and its modification, the profile likelihood method, the higher order profile likelihood method, the Hennion-Kopas method, the bigger stuff and Tweedy, 3 resampling methods, and the Bayesian credible intervals. So the question now is, should we consider adding any of these methods in Revman, since also most of you use Revman? To answer this question, we need to take into account the comparative study results that we identified, for example, in our review. And we can start by the results, the simulation results that say that the wall-type methods perform well only when we have a large number of studies in the meta-analysis. So we need to be cautious when we only trust the results with the wall-type method. And these methods, all these methods, the 3 methods, depend on the number of studies, the heterogeneity estimator, and the heterogeneity magnitude. Coverage for the already implemented in Revman wall-type method with the normal distribution can be as low as 65% when we have high heterogeneity and 2 or 3 studies in the meta-analysis. So we need to be extra cautious in these cases. Coverage is improved with the other 2 wall-type methods using the t-distribution or the quantile approximation, but they can be very conservative when we have only a few number of studies, a handful of studies in the meta-analysis. So should we implement any of these in Revman? Probably no. We would probably say no here. Then the Hartung-Knapp Selig-Jonkman method provides wider confidence intervals compared to the wall-type methods. Simulations show that it is not influenced by the magnitude or heterogeneity estimator, and it is also insensitive to the number of trials. Simulations also show that it performs well for both continuous and dichotomous data, but it can be suboptimal to the wall-type method when we have rare events and in the absence of heterogeneity. Caution is also needed when we have fewer than 5 studies in the meta-analysis, and these studies have unequal different study sizes. So in such cases, the modified Hartung-Knapp method has been suggested and is preferable. But again, caution is needed when the number of studies is too small. For example, when it is equal to 2 and we have only a small number, a small heterogeneity, as the method can be over-conservative. So in the question whether we should implement any of these in RevMan, we would probably say yes to both of these methods. Then the profile likelihood method has higher coverage compared to the wall-type methods, even for a small number of studies. And the higher order likelihood confidence intervals improve coverage, even when heterogeneity increases and the number of studies decreases. However, again, caution is needed when we have fewer than 5 studies in the meta-analysis, as the methods can be over-conservative. And at this point, of course, selection between the methods is a matter of power and coverage. So in the question whether we should implement any of these in RevMan, we would probably say yes, but we need to consider that the methods are iterative methods and they are not easy to implement. Then we have the Henry and Koppas method that performs better than the wall-type, Hartung-Knapp, and profile likelihood methods when we have more than 10 studies in the meta-analysis, but it doesn't perform well for fewer than 10 studies. Then we have the Biggerstaff and Tweedy method that has comparable coverage to the wall-type method, and the resampling methods that outperform both the wall-type and the profile likelihood methods. So in the question whether we should implement any of these in RevMan, we would probably say yes to the resampling methods, but again, we need to consider that the methods are iterative and computationally intensive. Finally, we have the Bayesian credible intervals. That studies have shown that have better coverage than the Hartung-Knapp, Selig-Jonkman, and profile likelihood methods, and they may even be more precise than the Hartung-Knapp approach. But again, as we said previously, they can vary depending on the prior assigned to the between study variance. So in the question whether we should implement any of these in RevMan, we could probably respond positively, but we need to consider that these are computed in a different framework than what we already implement in RevMan. Now, there are several software that we can implement the aforementioned methods, and as you can see, the wall-type method with a normal distribution is the most popular one, and it is followed by the profile likelihood method. Now, using the same 4 illustrative examples that I presented earlier, we compared the different confidence interval methods that we identified in this review. Overall, as you can see, and across all meta-analysis, all methods give similar results. There may be small changes in the magnitude of effect and mainly in the precision of the interval, but in particular, you can see that the wall-type with a normal distribution method lies among the narrowest confidence intervals. The Skovgaard statistic that belongs to the higher order likelihood methods and the Bayesian credible intervals lie among the largest intervals. Then the modified Hartung-Knapp method has the largest width for low and very low I-square values. For moderate I-square, the Henry-Koppas has the widest confidence interval, whereas for substantial I-square, the Hartung-Knapp-Seydig-Jungmann method has the widest confidence interval. Now, another important aim in decision-making is the prediction of the true effect size in an individual study and setting. Although prediction intervals provide additional information to the confidence intervals and provide useful information, they have not often been employed in practice. And I know that these prediction intervals are not included in Revman, that most of you use, but we plan to also include prediction intervals in the future. So prediction intervals are particularly helpful when we have substantial heterogeneity and the combination of the individual studies into a meta-analysis is not advisable, since we can infer on the range of these values. However, an empirical study shows more than 70% of the statistically significant Cochrane meta-analysis with heterogeneity positive may have a null or even in the opposite direction effect size in a new study. And the disadvantage here is that simulations suggest that the prediction intervals perform well for large heterogeneity and similar study sizes, but for small heterogeneity and different study sizes, their coverage can be as low as 78%. Before I conclude, I would like to hear your thoughts, having heard all of this information so far. I know this is a lot of information, but I would like to hear your thoughts on whether we should consider more between study variance estimators in Revman. Great. So the majority of you believe that we need to add more estimators, more between study heterogeneity estimators, because the results are sensitive. And I would probably agree with that. And although so far research has not concluded to which one is the best, I believe adding more options in Revman would probably increase the quality of the results. Okay, so now I would also like your opinion about the confidence interval methods for the overall effect size. Do you think we should add more than the currently existing method, more methods? What do you think? Great. So again, the majority of you believe that we need to add more methods in Revman, and also some of you believe that yes, we have to, not only because these are sensitive, but also because we haven't concluded to which one is the best. Great. So, in summary, the wall-type method using the normal distribution and the Dersimonian and Laird methods are the default methods in many meta-analytical software. And as we saw, better alternatives exist to the Dersimonian and Laird. For example, some of them can be considered the Polen-Mandel and restricted maximum likelihood methods. And we can use the Q-profile and the Jackson confidence interval methods to calculate the uncertainty in the between study variance. The likelihood-based methods are better alternatives to the wall-type method for the overall effect size, but these are computationally more demanding. Overall, the Hartung-Knapp-Seydig-Jungmann approach has one of the best performance profiles, but as we said, caution is needed when heterogeneity is 0. And in such cases, the modified Hartung-Knapp approach could potentially be performed. Also, Bayesian methods could be preferred when we have prior information available. But in general, what we suggest is to conduct a sensitivity analysis using 2 or 3 methods as probably the best approach so far. When we have only a few studies, or if we have small studies and rare events, or a combination of all these 3 in the meta-analysis. And this is because heterogeneity in such cases is very difficult to be estimated. Some references, and I'm happy to discuss any questions you may have.